Okay, so good morning, friends. Let us start our discussion with the Z parameters for two-port parameters. So in previous class, we have finished up with Z parameters. So now we'll discuss with Y parameter. So I have already uploaded the notes on Moodle, and immediately after this or by end of this week, I'll update it on or upload it on our Google Drive also. Okay, because for this week you have to appear for the test of second unit. So, I have already uploaded that on the Moodle as well as our Google Drive. Okay, all the lectures are there on Google Drive also. So you prepare for the test of second unit, which will be held on Friday. Okay, I'll share you a Google Sheet in the same type as previous test, and you have to solve those problems. Okay. One more thing. Yesterday we have skipped our practical. So that practical will perform today by I'll send you the link after your second lecture. So it will be between 12 to 2. So probably at 12 o'clock or so, we'll cover that one of the practical. Okay. So let us start with Y parameters or short circuit admittance parameters. So as we have seen, two-port network is simply a black box having two ports, 1 dash as one port and 2 dash as the second port. We have assumed that the current and voltages at port 1, they are V1 and I1, and voltage and current at port 2, they are V2 and I2. And the polarities are this one, or the upper half is the positive and negative. This is positive and negative. So 1 and 2 terminals, they are having positive polarity, and 1 dash and 2 dash, they will be connected to negative polarity of the voltage source. And current I1 will enter in I1 and current I2 will enter in 2 node. Okay. So with these assumptions, we have seen that for Y parameter or admittance parameter, you have to express these. There are 4 variables now. So you have to express 2 variables in another 2 variables. So 2 will be dependent and 2 will be independent. So in case of Y parameter or admittance parameters, current I1 and I2, they are the dependent parameters, and V1 and V2 voltages, they are the independent parameters. That means you have to express I1 and I2 in terms of V1 and V2. So I1 as a function of V1 and V2 and I2 as a function of V1 and V2. So if you will express it in this form, then the coefficients of V1 and V2, they will represent Y11 and Y12 parameters, whereas the coefficients in second equation of V1 and V2, they will represent Y21 and Y22 parameters. So this we have already seen yesterday also. So equation I1 is equal to Y11 V1 plus Y12 V2. Let us say this is equation 1, and I2 equal to Y21 V1 plus Y22 V2. This is second equation. So these are the equations in linear form. Same you can represent in matrix form. Now you know I is equal to Y into V. So I matrix, you have to express it in terms of Y matrix into V matrix. So I matrix elements are I1 and I2. So there will be simply a column matrix. And then Y matrix, it is a square matrix of Y11, Y12, Y21 and Y22. And again voltage matrix, it is a column matrix of V1 and V2. So that the same equations, equation 1 and 2, you can form it from this matrix as I1 is equal to, in this matrix multiplication is row by column. So for first row, first element I1, first row into column. Then for second element I2, second row and column. This multiplication you have to do. So I1 is equal to Y11 V1 plus Y12 V2. So this is equation number 1. And I2 is equal to Y21 V1 plus Y22 V2. This is your second equation. So these are the equations of Y parameters. From these equations, you can draw its equivalent circuit even, same as that of your Z parameters. So the transmission line we have shown here. Then this V1 and this I1 are for port 1. This Y11 and Y12 into V2. So here now it will be a dependent current source, but it is a voltage dependent current source. In Z parameters, it was current dependent voltage source, as there were polarities here. So now you can express it as I1 is equal to Y11 V1 plus Y12 V2. So this is for input side, that is equation number 1. And for output side, from equation 2, you can write I2 equal to Y21 V1. So I2 equal to Y21 V1 will be the dependent current source now, which is depending on voltage V1 on primary side. So Y21 V1, this is the current source, and then I2, second part of I2 is Y22 V2. So I2 is equal to Y21 V1 plus Y22 V2. This is the output part of the network. So this is the equivalent circuit of Y parameter. And then parameter evaluation, how to calculate the values of Y11, Y21, Y12 and Y22. So these you can calculate it from the equations 1 and 2. So from equation 1, if you will substitute value of V2 as 0, then you will get, this term will vanish. So you will get I1 is equal to Y11 V1. So from this, you can find out Y11 is equal to I1 divided by V1. So Y11 is equal to I1 divided by V1 at V2 equal to 0. Similarly, from equation number 2, you can find out Y21. When you will substitute V2 as 0, then this term will vanish. This term will vanish, and that's why I2 will be equal to Y21 V1, and from this you can calculate Y21 is equal to I2 upon V1. So I2 upon V1 at V2 equal to 0. So these two values we have calculated. Similarly, these two values you can calculate by substituting value of V1 at 0. So in equation 1, if we will substitute V1 at 0, this term will vanish and you will get I1 is equal to Y12 V2. That's why Y12 is equal to I1 by V2. So I1 by V2 at V1 equal to 0. And from equation 2, if you will substitute V1 at 0, this term will vanish. So I2 will be equal to Y22 V2. So from this, Y22 equal to I2 upon V2. So this is at V1 equal to 0. And no need to remember even these equations. As you know, Y or admittance, it is equal to I upon V, that is current divided by voltage. Whereas impedance in previous case for Z parameters, impedance you have calculated by V upon I. So that is V upon I is the impedance, and admittance if you want to find, then admittance Y is equal to I upon V. So if you want to find Y11, this first coefficient or first Y11, so this first coefficient will be for numerator and second coefficient will be for denominator. So Y11 will be I1 by V1 at V2 equal to 0. Y12 equal to I1 upon V2 at V1 equal to 0. Y21 equal to I2 upon V1 at V2 equal to 0. And Y22 equal to I2 upon V2 at V1 equal to 0. So from this you can easily find out the parameters, Y parameters. Okay. And how to calculate this from a network, given network. So let us see that first and then we'll move to the numericals. So Y parameters or short circuit admittance parameter, if a two-port network is given to you. So this is port 1, this is port 2. So we'll assume that current I1 is entering in port 1, voltage V1 is applied at port 1, and I2 is entering in port 2, and V2 voltage is applied at port 2. So with this assumption, the matrix I matrix, you can express it as Y matrix into V matrix. So that means this I1 and I2, a column matrix, and Y parameters, a square matrix, into V matrix, that is a column matrix. So this we have already seen. From this matrix form, you can write these equations also. That's I1 is equal to Y11 V1 plus Y12 V2. So this is equation 1, and equation of I2 as Y21 V1 plus Y22 V2. This is second equation. Now, if you want to substitute V2 as 0, if you will substitute V2 as 0, then in both these equations, you will get values of Y11 and Y21. Now, how to make voltage 0? If you will short circuit any port, its voltage, short circuit voltage is 0. In impedance parameters, for calculating impedance parameters, we need to make this current to 0. How to make current in a port as 0? If you will open circuit the port, the current flowing through that port will become 0. So here we want voltage to be 0. So we'll short circuit this port and we'll apply voltage here. So shorting the output port, that is V2 equal to 0, and V1 is applied at the input. So from these two equations, you will find I1 equal to Y11 V1 and I2 equal to Y21 V1. And from this, Y11 will be I1 by V1 at V2 equal to 0. And this is referred as the input driving point admittance. Z11, it was referred as input driving point impedance. Here, this Y11 is referred as input driving point admittance, as it is admittance. Okay, then Y21, it is I2 upon V1 at V2 equal to 0. This is forward transfer admittance function. So as Z21 was forward transfer impedance function, this will be forward transfer admittance function. Okay, and similarly, shorting the input side, you can make V1 as 0. So as you will make V1 as 0 by shorting input terminal, these two terms will vanish from these equations, and you will be able to find Y12 and Y22 parameters. So Y12 and Y22 parameters, you can find it as I1 by V2 at V1 equal to 0, and y22 equal to I2 upon V2 at V1 equal to 0. Whereas this y12, it is referred as reverse transmission admittance parameter or admittance function. Z12, it was reverse transmission impedance function. This is admittance function. That is the only difference. And y22 is output driving point admittance function. Z22 was called as output driving point impedance function. So this is, so nomenclatures are almost same. So no need to mug up the things even. Okay. So with this, we'll start solving the numericals of y parameters. So let us take the same numerical. Purposely I have taken the same numericals. You can take even different numericals. Okay, so T parameter, T network is given to you. So 20, 30 and 40. So this T network is given having two ports, 1, 1 dash and 2, 2 dash. Find y parameters of this. So that is the question. Now, first, for any two-port network, for finding any parameter, you have to assume first that the voltages and currents in both the ports. So let V1 and I1 are the voltage and currents at port 1, while V2 and I2 are the voltages and currents at port 2. You can redraw this diagram and you can show these voltages and currents here. So this is the actual circuit diagram which is given to you, a network, and for this network you want to find its y parameters. Now there are again, as for z parameters I have told you, there are n number of methods to solve this problem. So same way, same number of methods are there to solve this problem also. So in finding z parameters, we were interested to express V1 and V2 in terms of I1 and I2. In order to find y parameters, we are interested to find equations of, or we want to express I1 and I2 in terms of V1 and V2. Okay. So by any way, you have to express I1 and I2 in terms of V1 and V2. So first method, I have solved all the methods for first numerical, and second onwards, you can implement any method out of that. Okay. So method 1, find z parameters, and from z parameters we'll find the y parameters. So one method is you find z parameters, as now you are familiar with calculating values of z parameters. So even if you will find z parameters, you will be able to find y parameters. How? Let us see this. So this is the network, T network, and its z parameters, which we have already found out as first problem in z parameters. Same network. So first you take these two loops and apply KVL for this loop 1, and then apply KVL for loop 2. So by applying KVL to loop 1, we'll get V1 equal to 20 I1 plus 40 into I1 plus I2. So this is the equation for after applying KVL for first loop or first mesh. So rearranging the equation, that is clubbing all the terms of I1 together, I2 together, and voltages together. So from this we'll get V1 equal to 60 I1 plus 40 I2. Okay, this is equation number 1. Now apply KVL for this second loop. If you will apply KVL for this second loop, then it is giving you V2 equal to 30 I2 plus 40 into I2 plus I1. Okay. Now again simplify this equation, club all the terms of I2 together, I1 together, and voltages on other side. So V2 equal to 40 I1 plus 70 I2. So this is second equation. Now these equations you got V1 in terms of I1 and I2, V2 in terms of I1 and I2. And we know that from standard form of Z parameters equation, the coefficients in first equation, the coefficient of I1, it is nothing but Z11, coefficient of I2, it is nothing but Z12, coefficient in second equation, coefficient of I1, it is nothing but Z21, and this coefficient is Z22. So from this, we can get the values of Z11 as 60, Z12 as 40, Z21 as 40, and Z22 as 70. So this we have already calculated in first problem of Z parameter. Now, after this, we can calculate the Y parameters as Y11 is equal to Z22 upon determinant of Z, Y12 as minus Z12 upon determinant of Z, Y21 is equal to minus Z21 upon determinant of Z, Y22 equal to Z11 upon determinant of Z. Okay, so these you have to remember, and from these you can calculate this value of Y11 as determinant of Z. You calculate it once. So matrix of Z is this 60, 40, 40, 70. So determinant of this will be this into this. So 60 into 70 minus 40 into 40. This into this minus this into this. So its determinant value of Z is 60 into 70 minus 40 into 40. So this is at the denominator, and at numerator it will be Z22. So 70 upon this determinant. So that is coming as 0.0269. And for admittance, as admittance is a reciprocal of impedance, the unit of impedance is ohm. So its opposite of that is mho. So ohm symbol, you are drawing it exactly a mirror image of this mho. Or even spelling, you are writing it as OHM, and here you have to write it in opposite manner, MHO. So that is mho. So ohm and mho. So mho is the unit of admittance, whereas ohm is the unit of impedance. Okay. So this is Y11 parameter. So Y12 dividing, simply you have to do this division. So it is coming as minus 0.0154 mho. Y21 is minus 0.154 mho, and Y22 equal to 0.0231 mho. So these parameter values we have got as Y11, Y12, Y21 and Y22 from one method. So which was the method? From Z parameters you have calculated value of Y parameters. You can calculate Y parameters even directly. So that is method 2, use node analysis. So as I have already told you in previous class also, you can use node analysis even, you can use mesh analysis even to find the equations of currents in terms of voltage. So in finding Y parameter, what we are interested in? We are interested in finding the equations of currents in terms of voltages. So I1 should be function of V1 and V2, and I2 should be function of V1 and V2. So these equations we want, we'll calculate it from the node analysis. So and then compare it with the standard form of Y parameters. So standard form of Y parameter equations, I1 is equal to Y11 V1 plus Y12 V2. So that means coefficient of V1 is Y11, coefficient of V2 is Y12 from equation 1, that is I1 equation. And from equation of I2, the coefficient of V1 is Y21 and coefficient of V2 is Y22. That is I2 equal to Y21 V1 plus Y22 V2. Okay. So this is the network. I have redrawn it. V1 is the voltage applied at port 1. I1 is the current flowing in port 1. V2 and I2 are the voltages and currents of port 2. Now for node analysis, how many non-reference nodes are there? That you have to find first. So in this network, only one node is there. Okay, that is this, where I have kept this cursor. So this is node 1, but while assuming the voltage at this particular node, I have to take care that we have assumed voltage at port 1 is V1 and current entering in port is I1, and V2 and I2. These are the voltage and currents at port 2. So except this V1, V2 and I1, I2, now we have to assume the voltages and currents in the network. Okay, so this thing you keep in mind. Otherwise, you may write V1 here as a voltage of first non-reference junction, and at the end you may get confused by this V1 and this V1 voltage at port 1. Okay, so that's why while assuming, you have to take care that now V1, I1, V2, I2, these are the voltages and currents at the ports only. So for junctions, don't take. So I think I was disconnected for some time. Am I audible now?
Yes, sir.
I'll reshare the screen. Yes. Is it visible to you?
Yes, sir.
Ah, right. So, I lost the cursor. Okay. So for this junction, I have assumed the voltage as V3. V3 is the voltage at this junction, and what we have to assume in node analysis, we have to assume all the currents, they are outward, going outward from the junction, right? So I3 is moving outward, I4 is moving outward, and I5 is moving outward. I have purposely left the symbols V1, V2, I1 and I2. So currents are starting from I3, I4 and I5, and voltage is V3. Okay. Now apply KCL at this junction 1. If you will apply KCL at this junction 1, it will be simply I3 plus I4 plus I5 equal to 0. Now find value of I3, I4 and I5. So I3 will be V3 minus V1 upon 20. So V3 minus V1 upon 20 is value of I3. I4 value you can calculate from this, V3 minus this reference voltage, which we have considered as 0 volt. So this V3 minus 0 upon 40. So that is V3 by 40 plus V3, this I5 value, V3 minus V2 upon 30. So V3 minus V2 upon 30 equal to 0. Now this is the current equation in terms of voltages. Now find out the LCM of this. So it is 120. Multiply this numerator by 6, multiply this numerator by 3, multiply this numerator by 4, so that you will find 6V3 minus 6V1 plus 3V3 plus 4V3 minus 4V2 equal to divide by 120 equal to 0. This, take this 120 on that side and then simplify this equation, that is club all the terms of V1 together, V2 together and V3 together. So you will get V3, 13V3 minus 6V1 minus 4V2 equal to 0. So from this equation, we are not interested in terms of V3. So we'll find out value of V3 from this equation and then we'll substitute it in some other equation. Okay. So that we'll get only equation in terms of V1, V2, I1 and V1, V2, I2. Okay. So V3 equation is 0.46 V1 plus 0.31 V2. I have got. let us say this is equation number 1. Now, I have got this equation. Now, I1 is equal to V1 minus V3 upon 20. So, from this I1, if you want to find this I1 is nothing but it is minus of I3, or you can find I1 as V1 minus V3 upon 20, and I2 you can find as V2 minus V3 upon 30. Now V3 value we have already calculated from this equation number 1. So you can substitute this value of V3 here. So I1 is equal to V1 minus V3 upon 20. Put value of V3 from equation 1. You will get this I1 is equal to 1 by 20 V1 minus 1 by 20 into this V3. You substitute from equation 1 and then simply rearrange the terms, that is club all the terms of V1 together, V2 together. You will get the equation of I1 as this 0.027 V1 minus 0.015 V2. Let us mark this is equation number 2, which we have got as I1 in terms of V1 and V2. So these coefficients we know they are Y11 and Y12. So similarly, to find values of Y21 and Y22, we'll find the second equation I2 equal to V2 minus V3 by 30. Substitute the value of V3 in this. You will get I2 equal to 1 by 30 V2 minus 1 by 30 into this value of V3 from equation 1. Then rearrange this equation, club all the terms of V1 together, V2 together. You will get the equation of I2 as this in terms of V1 and V2. Mark this as equation number 3. Now equation 2 and 3, you compare it with the standard equations of Y parameter and you will be able to find the coefficients as Y11, Y12, Y21 and Y2. So this is second method. By second method also we have got the same values of Y parameters. Now third method, use of mesh analysis. So use mesh analysis and find out the equation of currents from in terms of voltages, that is I1 as a function of V1 and V2 and I2 as a function of V1 by 2, and then compare it with the standard form of Y parameters equation. Okay, so this is the network. I have redrawn it. Now apply KVL to mesh 1 and mesh 2. You will get these parameters. Now you can, if you want to find Z parameters, simply this is equation of V1 in terms of I1 and I2. So coefficient of I1 is Z11, coefficient of I2 is Z12. But we are interested in finding current or the Y parameters, admittance parameters. So we want current equation in terms of voltage equation. So how to do it? So from this equation 2, now you can find value of I1. So I1 in terms of V2 and I2. You substitute this value here and you can get this equation in terms of only I2, V1 and V2. Okay. From this equation 2, you can find value of I2 and substitute it here in equation 1, so that you will get equation of V2, I1 and I2. So you will get the two equations which are the desired one. So simple way is you find out value of I1 once from equation 2, substitute it in equation 1, find out equation from equation 2 value of I2 in second time and substitute it in equation 1. You will get two different equations of V1 and V2 in terms of I1 and I2. So from equation 2, I2 is this equation, 1 by 70 V2 minus 40 by 70 I1. Now put this value of I2 in equation 1 and rearrange this or simplify. You will get the expression of I1. It is only V1, V2 and I1 terms. Take this I1 equal to V1 and V2. So in terms of V1 and V2, we got this equation. Mark this as equation 3. Now again from equation 2, we have found out value of I1 in terms of V2 and I2 and substituted it again in equation 1, so that you will get V1 in terms of V1 and V2 and I2. These are the only three terms, and we want to express I2 in terms of V1 and V2. So rearrange this equation in such a way that you will get the value of I2 in terms of V1 and V2. Now this is equation number 4. Compare this equation 3 and 4. You will find that the coefficient of V1 and V2 will give you the parameters y11, y12, y21 and y22. Again, in this, by this method also, we have got the same answer for y parameters. Okay, as time is running out, we'll cover fast method number 4. Keeping one port as short circuit and find y parameter using ratios of voltage and current. So short circuit case 1 and 2 will take. First case 1, short circuiting port 2. So we have shorted port 2, so that means V2 equal to 0. And V1 we have applied here. Now this is simply a network. You can apply mesh analysis for this network to find KVL, to apply KVL for both these meshes. So after short circuiting port 2 and applying V1 at port 1 and I1, I2 are the same currents in entering in both the ports. So applying KVL to mesh 1 and 2, you will get V1 equal to 20 I1 plus 40 I2 equal to V1 is the first equation, and for second loop 0 equal to 30 I2 plus 40 I1 plus I2. Okay, so that is 70 I2. So this second equation, from this now you can find from equation 2, you will get I2 equal to, once find value of I2 in terms of I1 and substitute it here, you will get one ratio. Then in second time you calculate value of I1 in terms of I2 from second equation, substitute it here, and you will get the second value. So from equation 2, now I2 is minus 40 by 70 I1. Put this value in equation 1, so that you will get V1 equal to 60 I1 minus 40 into this value of I2 as 40 by 70 I1. Then after simplifying this, I have got 37.143 I1. So V1 equal to 37.143 I1. Now you know Y11 is I1 upon V1. So if I will take I1 and divide by V1, this constant on another side. So I will get Y11 it is equal to I1 by V1 at V2 equal to 0 equal to 1 upon 37.143, which is resulting it as 0.0269 mho.